Okay, in this video I want to talk about member function definitions again. We've already seen that we can define our member functions inside the class definition. So here's a quick example. I have class GameStats again. It has a private member current level, which is an integer. I set that to 7. Just for an example, you should probably set that to 1, but in any case, then in the public section I have the function getCurrentLevel, which will return current level. Now from this you'll also notice that I prefer to put the public section first, so the public member access modifier, and then typically I'll put private last. Now in other examples and in some textbooks you might see those reverse, you might have private first and public last or something like that. Now again, going forward we'll separate these out. You'll have a class in one file, your class definition in one file, and then you'll use that definition in some other file where you actually write your code in main or something, right? And it's often the case that you switch back and forth between, let's say, your main file, so where you actually create instances of that object, and between the file that contains the class definition. So you're switching back and forth between those because you want to see the members that are available to you or that are public. So it's often the case that you'll do that, so you switch to the header file, which we'll talk about later, and you want to navigate quickly to the public section so that you can see the public members, the member functions and so on. Maybe read some of the comments and then you can start working. You don't always know what functions are available to you. Of course you can do the object and then dot, and then the IntelliSense will give you a list of functions and such that are available and the accompanying comments, but it's also useful to switch to the header and take a quick look at the definition. But the point is, when you do that, you want to quickly navigate to the public section, right? You don't want to scroll through a bunch of private members and helper functions and so on. You want to get to the public section quickly so that you can see what you can use. Alright, so for that reason I prefer to put public first, and of course if you add more members to the public section, the private section will shift down. I like to use Unreal Engine where I can to explain certain things to you, because I like to show some of the things in context of a real-world program. Not that you can't write small C++ programs that are useful, but I like to use Unreal Engine examples for a couple of reasons. Firstly, it's more representative of what an actual program will look like. Most production programs are not small, right? It's not small as we have done it so far. Secondly, you won't always be using the C++ standard library utilities. You may make use of some API, such as what is provided by Unreal Engine, or maybe the Qt libraries, also referred to as Qt. They often have their own implementation of various things for various reasons. So I feel it's important to highlight that idea to you, and then also thirdly, I like to show some of the coding standards or conventions that you'll be using in real-world production environments. Not just going based off of my opinion, but on what is actually used in production, right? So I'm at this page, Coding Standards in Unreal Engine. There are a few interesting points here. You can read through if you want. I'll link you to this page. But what I'd like to talk about is what we've discussed previously on class organization. Classes should be organized with the reader in mind, since most readers will be using the public interface of a class. That should be declared first, followed by the class's private implementation. Now what is an interface? That's basically the definition of the class, and it's basically in the header file. Again, I talked about the difference between a header file and a source file. I'll talk a bit about that again later on in the video. But what if we want the member function definition to be outside of the class definition? Again, I'm referring to the class definition here. It's also correct to say it's a declaration, but it's basically a declaration and a definition in this case, as I explained in the structs lesson, right? I just prefer the term definition because we are not just declaring it here, we are also defining the class. Here we have GameStats again. In the public section, I have getCurrentLevel, opening and closing parentheses, and I end that off with a semicolon. And from the lesson on functions, that should be familiar to you, that is a declaration of a function, or the prototype. So in the previous slide we defined it right here, but this is just the prototype. Now we're going to define it later on. At the bottom of the slide we have the definition of the function. You'll see this is sort of familiar, but there's a bit of a change to what you are familiar with from the lesson on functions in Module 101. We have the return type, which is an integer. In the body of the function we do return current level. Where does that come from? Well, it is in the class definition, right? Our member functions all have access to our other members, so our data members or member variables. So that is why we have access to current level here. We can return it. The difference in this header here is that we have to prefix the function name, which is getCurrentLevel, with the name of the class, which in this case is GameStats, and then we do 2 colons. If you remember from the lesson on namespaces in the first module, this is called the scope resolution operator. If you remember from the first module, if we don't have using namespace std at the top of our file, then we have to prefix things like cout or cin with std and then : . So basically in this way we tell the compiler that the standard library code that we need is in the standard namespace. As you can see, we use the scope resolution operator here with classes too, and we do that to specify the class to which the member function belongs. Remember that at this point we don't have an object or an instance of that class created. So this is different from a member accessor where you do some object dot and then the member, or if it's a pointer to an object you do the pointer, the arrow operator and then the member. This is more to do with scope. You are telling the compiler what class does this function belong to. Of course, what this allows us to do is we can have the same function name in two completely different classes. So an example will be toString, where you basically print out the state of an object at some point in time out to the console, right? You can do some object.toString, so you can have two completely different classes, maybe a GameStats class and an enemy class, and you want to get the state of both of those. Then both of those classes can have a toString function, and both of those simply print out the state of that object, in whatever formatting you want to do that. And you won't have any conflicts because the function name, again let's say it's toString, is within the scope of that class. And also remember in the lesson on functions, you had some function prototype at the top of the file maybe, and then later on you had the definition. So in other words, the prototype or declaration was global, right? It was accessible to that definition that you do later on. But that's not the case here because it is within a compound statement, it is within the body of a class. What is inside some compound statement or body is typically not accessible following that body or compound statement, right? And that's the same thing with bodies or function definitions and class definitions. So you can access the members of a class again using the class name and then doing 2 colons. That's again like saying, go look in that folder. That folder has some member that I want to use in this context. So maybe if you think of it in that way, maybe it's easy to remember. Quick example again in Visual Studio. I have the class GameStats. In the public section I have two functions, getCurrentLevel, setCurrentLevel. We've talked about this before. GetCurrentLevel will return current level, setCurrentLevel will set the level to what we pass in. And then this here I'll actually just change to 1 by default. Okay, and then in main I have an object, game. I create an object game, an object of type GameStats. Then I do game.setCurrentLevel, I set that to 15 and then I print it out using getCurrentLevel. So what we can do with this now is we can separate the definition out. So I'll actually just cut that out, do a semicolon at the end, right following the class definition or body. I'll do int. Where is this function that we want to access? Remember that the function is within a body, so we're basically within a compound statement. It's similar to a compound statement, right? So we don't have direct access to that. So I do the colon, and then you'll see the member show up. I'll do getCurrentLevel. And that is it for our getCurrentLevel. And I'll do the same thing for setCurrentLevel. Now if you want to, you can go and copy this entire header. Just remember you need to resolve that scope, so GameStats : and I'll paste that in. Okay, so now in the class we have the declarations or prototypes, and then we can go and define them outside of the class. Build and run and that will work fine. Prints out 15. That means setCurrentLevel works properly and getCurrentLevel works properly as well. Earlier on in the video I mentioned I like to show you some things in context to a real world program. And again, I prefer to use Unreal Engine as an example. So I have a small game that I wrote here. This class that we are looking at represents a tree that's going to move left and right on the screen. That tree will spawn apples that the player is supposed to collect with a basket. So just a small game and a simple project. I just wanted to show you an example. There is code in here that you won't understand, such as these macros and so on. So don't worry about that. But what we can see here is familiar keywords. So we have class, and the class's name is TreeBase. It starts with an A because it's an actor. We actually have inheritance here as well. We'll talk about that later. But we can see we have a public section. Protected is similar to private, but we'll also talk about that in the inheritance lesson. If I scroll down, we finally have private. You'll also notice that you have functions in here, actually in the private section here. Alright, I'll scroll up. Now you'll notice this is treebase.h. This is the file name. This is called a header. or an interface file, then you have a corresponding source file. This is treebase.cpp. The source files typically end with .cpp, and it is essentially a implementation, right? It's the implementation file. The interface file is what the programmer will interact with. So I've talked about including files previously. If you want to use code written by someone else, you typically have to include the relevant file. So if you wanted to use this class aTreeBase, then we need to go and include this treebase.h file. So I'll actually switch over, because you can see this statement here ends with treebase.h. So I have that file included because I want to use that here. And I'll scroll down just a bit. So here, for example, we have void, the class name, ::spawn apple, which is the function that I mentioned previously in the header file, and this does some stuff, right? And you can see this is a simple game, but we already have nearly 80 lines of code in here, okay? So that's one benefit of separating your files out. You can split them up, and in that we have a shorter interface to work with. But let's say I'm in this file now that includes treebase.h, right? Okay, so I know the class name and I want to look at the interface. So I go to the file that contains the definition of the class, treebase.h, and I want to do this because I want to see what functions are available to me. So I can do the object name, dot, and then I can access the members. Now, if that is code that is provided to you, then you can always go and look at the documentation, but you want your code to sort of be self-documenting, and you'll often go and look at the header files and the interface, so under the public section, to see what is available to you as a programmer, right? So let's say public was last and all of this stuff was private, then I'd have to go and scroll and scroll and scroll, and then finally I can see the public section and what I have available to me. Well, that is why we put public first, so that we don't have to do that. And again, this is just a few lines. This can be a huge file, depending on the program.